So after reading chapter 1 this week, I took some notes on the different things that I read and learned. And so the chapter first started talking about the Big Bang Theory, and I knew some information about the Big Bang Theory before, but didn't know many details about it. So this was interesting that it talked about how all the energy and the matter in the universe was initially concentrated in an extremely hot, dense singularity, much smaller than an atom, so super small. But then the explosion occurred, which had everything expand rapidly, and the temperature initially began at 10 billion Kelvin, which is super hot, like way hotter than the sun. But then over time it cooled and other particles were able to form, and like parts of atoms like the protons and everything were able to form to create the earth. It also talked about how there are tons of galaxies, and all the galaxies are composed of clumps of stars, which then our galaxy is the Milky Way. It's composed of 200 billion stars, but then it also has the planets and everything in the sun. And it's shaped like a flattened disk with a thickness of about 1,000 light years and a diameter of about 100,000 light years, which is pretty large, obviously. And the galaxies are found in clusters, so it's interesting that we don't know much about some galaxies, but then other ones, like our galaxies and nearby galaxies, we know more information about since we can study them more easily. The chapter then talked about the origin of our solar system, and it began with a rotating cloud, or the nebula, which was a collapsed cloud of gas and dust that included material that was produced from older stars. And then the chapter also talked about the location of the planets compared to the sun and how it impacts their size. So the planets that are closer to the sun are much smaller in diameter and smaller in mass than the ones that are further away from the sun. And in the book, it showed a comparison between Earth and planets that were further away from the sun, and it was significantly larger. And so that was really interesting to see. And then I was also interested with the natural time periods, since the Earth rotations create summer and the winter solstices, and then the autumn and vernal equinoxes. It was interesting how the location of the sun and the Earth's rotation, like combined, can dictate the different parts of our seasons. And the lunar month is 29.5 days, and so that makes sense with our like calendar year. But I was also intrigued with the solar day being our clock day, but the sidereal day is 4 minutes shorter than the solar day. So I think that's interesting that we decided to add the 4 minutes to our day, and then I think that then correlates with the leap year and adding the extra day. So I thought that was really interesting. And it also talked about the parallels in the equator and how it's hotter towards the equator, and the gravitational pull at the equator being different throughout the rest of the Earth. The nautical mile was also discussed with latitude and longitude, how it was 1 minute of arc length of latitude or longitude for 1 nautical mile. It also talked about the zenith point, which is the spot directly above the reference point, and how the clock is set to noon when the sun is at the zenith point above the prime meridian. So that's how the time change occurs at the 15 degrees from that spot for the different time zones, which right above the median, above the prime meridian, is the Greenwich Mean Time, which is like the starting point, and then it moves on from 15 degrees for each time zone. But it also changes for, especially like in the US, they're not just going to cut it off in the middle of one area, because then people would be like commuting to work and changing time zones and stuff. So then I thought it was interesting that then they also looked at what was most convenient for people in the different time zones, if it was easier to cut it off at a certain point or not. It also discussed a lot about reservoirs containing a fixed amount of water at one instant, but then the amount changing with evaporation and then rain and different stuff. And so the movement of water throughout the reservoirs is the hydrologic cycle. And so then it discussed how transpiration is the release of water by plants, and sublimation is the conversion of ice directly to water vapor. The residence time for the reservoir is the average length of time that a water molecule spends in any one reservoir. So the reservoirs are constantly changing in levels and trying to maintain their same level as there's different amounts of rain and evaporation occurring. There was one section titled One World Ocean Divided into 5, and I've always thought that there were 4 oceans. So reading this, I learned about the Southern Ocean, so that was interesting since I didn't know that was considered an ocean before, or classified as like one of the main oceans. And so after reading all of this, I want to know more about how the oceans are divided and what constitutes each part of the ocean. Like, are there dividing segments, or do they just like flow into one another? I found it also very interesting that 70% of Earth's land masses are in the northern hemisphere and most of them are in the middle latitudes. But then in the southern hemisphere, it's mostly a water hemisphere where land is mostly in the tropical latitudes and then in the polar region. I also found it interesting that 71% of Earth's surface is below sea level and only 29% is above sea level. So there's a lot of stuff that we don't know exists and have yet to learn about in the ocean, since so much of the Earth is below sea level. My 3 questions for this chapter are: how are they able to consistently track the amount of water in the reservoirs? Like, obviously it's changing and they can estimate, but is there a way to track consistently how much is leaving and how much is going in? And they also discussed the extinction period and how only a few years and few weeks passed between when extinction struck the planet, the dinosaurs appeared, mammals appeared, and all other events occurred like leading up to this point. So how do they know the time period that happened between each of those events? And then lastly, how are the oceans able to be regulated with their salt levels and other factors to distinguish them from one another? Since one of the main differences between the oceans is the salt level and the density, but since the densities are different, they wouldn't be able to mix very well. So how are we able to regulate that so that at those points they are able to mix and still be habitable by the different creatures in the ocean? So those are my questions for this chapter.